So today we're talking about security. We're using the shared slide. I think this part of this book is all about how to prevent undesired outputs caused by malicious attackers and or misleading of inputs allowed by some functions combination. So this is about securing the app, because all through we've talked about building shiny apps, we've talked about converting apps to packages, we talked about testing shiny apps, we talked about a whole lot even before now. But at this point, we will talk about how to secure the app. And in quotes, for two, Ryan actually talked about this, and I think maybe about this chapter in like 15 minutes, but this 15 minutes were quite insightful. And I think he did a whole lot of explanation also. I think quote one also actually, I think Federica also did a very, very deep, detailed explanation on this same chapter. I checked both quotes, the previous quote videos, and it was quite amazing. But for this quote, I'll do as much as I can do to like go and discuss about what I kind of understand. And it may be more theoretical than practical, because it still looks amazingly interesting. So for this introduction, the security within your app, that's the data. And most times, basically, what exactly are we securing the app? Like your data, your personal information, and how it shouldn't get into the wrong user's hand. Then your computing resource, such as your server. You're trying to protect your server from being used in other malicious activities. Then publishing on shinyapps.io. This is also one of the discussion in this chapter. But I think there were some other there's another package or other packages that could be also that you could also utilize in publishing your Shiny app. So let's move to the next slide and start our discussion today. Okay, so introduction. In general, it is assumed that whoever deploys the app is responsible for the security between apps and within your app. Okay, but it is still very possible for an ineligible hacker to send values that are not expected. So based on what Hadley was saying here, he said securing your device by attackers is not exhaustive. How to do this is not like exhaustive. But if you check this particular shared slide, a lot of like, say maybe 5 to 6 ways to get this done. And you need to search for alternative solutions to the impossibility of stopping an attacker from invading your app and its context. It is important not to underestimate combination or substitution of functions that will be preventable errors in chain reaction. Okay. So let's just move to the next slide. The security within your app, two main security action, validation, and then isolation. I think we talked about isolation. Was it you or me? We talked about isolating data. I think isolation takes place more at the server side. The validation takes place more at the client side. So Shiny input use client-side validation, such as data that are user-specific and need the user to authenticate before use. Why the Shiny server function called isolation? One user cannot see data from another user in a different section. The only exception is if caching is in use. And we'll talk more about caching in the last chapter of this book, which has to do with performance. But so what isolation really is all about is ensuring that data from one app user does not get is not exposed to the other another app user. So first of all, we'll talk about data. Sensitive data and password are the most targeted objective of the attackers. For this reason, it's recommended not to store password in the source code of your app, eventually in a variable in the environment. So we advise here to use the .yml file to store login credentials, and use .gitignore to include the appropriate files containing your authentication credentials. Now, authentication and client-side validation. There's more than one alternative to authenticate. First thing is that you need to add some kind of layer between the user interface and the Shiny server, and this is called a proxy. So the proxy is like this middleman that takes information from the user interface and takes it to the Shiny server and bring back the let's say you're asking a question, brings back the answer from the server side, takes it back to the UI side for the client to see. So this pictorial representation here actually shows exactly what the proxy does in lay terms. Okay, asks Bob the current time, what the current time is. Then the proxy asks Bob, what's the current time? Then proxy also takes back the answer. So it redirects user to an authentication page, as in a login page, and once authenticated, to check whether the user is authorized, and then let them get access to the Shiny application. I think it's just like most application that will require you to log in before using any of the features. So I would see one example of such before the end of this discussion. So the following section lists 5 packages for configuration, authentication, and storage of login credentials. There are several options to choose from based on your need and design of the app. So we'll look at some packages now. This was like the first package that was suggested. I think something is not here. Maybe it's later on, but I saw it in the book. There was actually a link by in the book. It was a Shiny user R talk in Toulouse, and it was by Colin Gillespie. I'm not sure if I'm pronouncing that name right, but I think is the author of Efficient R Programming, and I didn't totally read the Efficient R Programming book, but I just looked through chapter 1 and 2 back then. I think some years back, I was trying to be able to maximize my laptop's capacity. I think then I was in a laptop that was a 2 GB RAM laptop. So I was trying to see how I can efficiently write R codes that I'll be able to still run and manage the RAM, but I really didn't go in depth. I think at the point I just stopped because I felt like I'd not known as much as I wanted to know before going as far as learning how to write efficient R programming. But I think writing efficient R programs. So I think I will still have to go back to that same book, because the next chapter, which is on performance, talked about using some packages that were mentioned in the efficient R programming book, such as Profis, I think Benchmark. Those packages were mentioned in this in the last chapter of this Mastering Shiny book. So let's get back to this. Now, the first package suggested by the book is the config package. It is used to manage environment-specific configuration values, and I believe we know how to install packages in R. So I think this snippet of code here talks about installing the package and loading the package. Then how to store password in a file with config. This actually will take us to a link that shows how this is done, and it even shows us just even more than using the config package. It shows us other alternatives that we could even consider. I think one that has to do with DNS. Permit me, I really don't know so much about this I'm discussing today, but I believe if we look at it together, we could pick a thing or two and come up with and be able to at least implement it in Shiny apps that we intend to build in the future. As with every program, I think yes, these were some instructions I also noticed in the book, which is about one, you don't put your password or your username on a plain text, and I think I mentioned some others before. Use the gitignore .gitignore, or you can use the .r environment file. And I think those are the things we also mentioned there. And first of all, we start with as with every programming language, it's important to avoid publishing code with your credentials in plain text. There are several options to protect your credentials in R. In order to prevent, here are the methods that we will cover. So this particular link, which I think I should just share, you can be able to go through this in depth. And I think the first one is about integrated security with DSN, then integrated security without DSN, and then we have encrypted credentials with the keyring package. Then we have the use a configuration file with the config package, which is what brought us here. This particular example is what brought us here, which is actually even suggested as fourth best option. Then environmental variables using the .r environ file. This is the fifth one. Then using the option base R command, then prompt for credentials using the RStudio IDE. So I think the integrated security with DSN, this has to do with you the very best solution concerns two species that are usually out of the hands of the analyst. There is integrated security between the terminal and the database, usually via Kerberos. I think this is the last of the 5 examples in the share slides. This is the last of the 5 examples in the share slide, which we would still look at today. And ODBC connection has been pre-configured in the desktop or server by someone with sufficient access right. The ODBC connection will have a unique DSN, which is a data source name. And this is going to consider the best option because no information about database or other than an initial alliance is available in plain text code. So I think this is like one of the best ways to get this done. And we have this other method. So I think this method is, I think I've seen this method before, and I saw it as one of the examples given in a data camp, in a data camp course, which has to do with importing and cleaning data. Because I think that's just that. Okay, I would move on, and I shared the link already. So in case anyone wants to, who's watching this video after now, probably wants to go through this, you can still check the book. You would find a link on the book, and the book is an open source. It's online. It's free for you to read through. So now the package makes it easier to deploy context, and in this context, it is used to keep the credential outside of the R script by saving them in the config.yml file while keeping it in the current working directory. Okay, I think we should check the fourth one, the one that has to do with the config. Yes, we should just check this. The config is meant to make it easier to deploy content, but we also use it to keep the credential outside of the R script by saving them in the config.yml file. In fact, all of the connection arguments can be saved in the YML file. So we have to install the package. If we don't have it already, then load the package. And then in the YML file, we can have this, we can have the user ID, the password, the ports, and the database name, then the server of the database, then the driver. Then this is PostgreSQL, and then we can come back here, and all we just need to do is to use this is how the connection arguments will be called inside the R script. So this time around, we only like this is similar to what we do. I think we've done this similar to what we do when we are using this advanced R. We're talking about I think discussed this before in one of the chapters, where you use this symbol to like locate should I say locate a variable, or let me say an object. And with this you can actually get the user ID, get the password, get the ports. And if you have this like this in an R script, you are definitely sure that okay, most of the things you need to get your tasks done are well protected in the YML file, and you're not bringing them directly on the R script, which will be there. I think this other method is also quite popular, using use environment variables. So the .r environment file, and the issue is you making the mistake of publishing this with when you are pushing the code, the script on GitHub. If you make this mistake, then everyone already have access to that. So it's always advisable to try as much as possible to keep the .r environment file safe and keep it away from do as much as possible not to publish it. Okay, I think you dropped the message. Let me check. Okay.
Yeah, I think that covers what you just went over. The use this package goes over credentials and mentions that if you've like set up your GitHub password in the .r environment, they suggest not doing that because of those potential flaws of accidentally sending those out on GitHub. Yeah, so that's what they recommended.
Okay, thank you so much for your contribution. Okay, so would move on from there. The package makes easier to deploy context, and this context, okay, I think we talked about this. Then the YAML TM are types of files made for making easier international collaboration with a language which is both human readable and computationally powerful. An example of a .yml file is a config file, and this is it. And to recall the information back from its directory, I think we've mentioned this before. You just use this config, then the $, then UID, and it fix the whatever is attributed to UID, and you get to use it for what you need to use it for. So this second package is the auto package. So I think I checked online what this auto means, and I think it is like an organization. I was trying to be sure if it was still the same organization. Secure access for everyone, but not just anyone. I think they are. I'm not so sure, but I think maybe this is they are the one. I'm not so sure, but let me just use the auto package and see if they did that. So I did that, but package, let me say R. Because when I was reading through, it seems as though, okay. It provides tools to log in and out a Shiny application using social networks or a list of emails. Okay. I wish I could know who exactly, maybe they were the ones or not, but Juliet, maybe if I check the names of those people online, maybe I would have found them, but that's not so important right now. Okay, pardon me, just give me a second. Let me check. I think my laptop's about to go off. Let me just plug it in. Okay, I'm back. So for this auto package, I think we just saw something about the package itself. Okay, let me just go through that again. Let's be sure so I said the right thing, because this is going to forever be on. You can be on YouTube for a long time. So it provides tools to log in and out of a Shiny application using social network or a list of emails. So that's exactly just what it does. And going back to this, we see it's an identity provider. It offers a server where to store Shiny apps, as well as procedures for setting credentials and access. You need an account where to load your app and set up the credentials. Then after you've done that, you would have an access to the YML file that will be created using the use auto function, which can be automatically positioned in the app.app directory, and it is already filled with basic information. So with that, you can then here's content of that YML file. You have the name, that's the name of your app, and the remote URL, auto config. Then you have the rest of the things, like then your credentials. Then you can set up the keys using the use this package, and which adds a .r environment file in your project directory for you to modify the content with alt o user, alt o key, alt o secret, and then you could get access to your auto user using the system.getEnvironment function. I think we saw something like using the system.getEnvironment function earlier. Okay, maybe not here, maybe somewhere else. Okay, so there's a third example, and I think we have something to practice with this particular third example, the Shiny Manager package. Now, a simple secure authentication mechanism for single Shiny application is through a Shiny Manager package. So there's a live demonstration of the potentiality of this package. So if you check the shared slide, we have these two links. Two links are provided, but the first one doesn't work, but the second one does work. So we will check this, and I tried the first one, it didn't work, but I could give it a try again to see if it will work this time. I think for the username should be this and password should be this, so I'll just try it again. Shiny, and see if it works. Oh, wait, it does work. Okay, or was it the second one? Okay, let's just move on. Okay. Okay, so we just saw like an example of the of the Shiny Manager package, how it works, and like what it means to have like a username, a password before you have access to an app. We just saw a demonstration of that, and then with this, it in particular it provides a function to secure app in which to wrap the UI as well as the server with the following command: secure UI.
Pardon?
Can you hear me?
Yeah, I can hear you.
Okay, good. So sorry. I think it's just my network here. It just went off. So back to this, the Shiny auth. I guess it means auto package is very useful for providing key information to use. This has a main function. I think I've seen this being used before. But I'll be honest, I still need to sit down and look at this whole thing again. These are the main functions which visibly call JavaScript with the command shiny.js and use shiny.js internally. So we have the login UI, the login server, the logout UI, and the logout server. It also provides a method of a cookie-based automatic login, which means that the system can store the credential for some time as established by the creator of the app. Then the fifth one, which is the Sodium package, I think it's a software library for encryption, decryption, signature, password hashing, and more. Generally used in the context of encrypting password is simple commands such as username equals the username in string format, then password, Sodium password store, then the password in string format, which releases the password in this format, password, then Sodium password store password. So it gives you this, should I call it a, yeah, I can call it a key. It gives you this, and then I think it's the hash. It gives you this hash, and then you can verify the hash if it's the password, and if it is the password, you get a logic return statement which is true. Okay, so another suggestion by the book is to use Kerberos. I think, okay, this is the pronunciation. Uh, uh, am I doing justice to this pronunciation? Trevin, or can you help me? Kerberos, is that correct?
That sounds right.
Okay.
That sounds
Okay.
right to me.
Okay. So this is like a computer network authentication protocol developed by MIT and classified as auxiliary military equipment. Okay. And then the whole story there. And the remit of the product followed with version updates and the implementation by other institutions included then Royal Institute of Technology in Sweden and the Stanford University made the system available outside the US with some limitation. Kerberos is available with RStudio Pro product. So this means if you would like to use Kerberos, you need to go for the Pro product of RStudio, which is now Opposite. So this is like free free marketing for Opposite. In general, what happens in an app when setting up login credential is described below. So I think we can look over this in a bit in more details a bit. In the UI, you can use this command to wrap in your code and build a module. While in the server, you should mind not to. Okay, I think it should be store any form of credential, but I said store them in separate file like XLM file, YML file, .rds file, .renviron file, and I think you just advise that the users package will need to ensure that one doesn't go mistakenly upload the R environment file. So the server should include the event reactive function to check whether the user login and password are valid credentials, raising a silent validation error. So if there's like an error, it should just be silently mentioned. So I think there is an example. I think this example is already in my RStudio. I could just show that. And then, okay, so just go straight to the book. Great. 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 Okay, there is it. Click on this. Okay. Yep, this is it. So I think if I use admin, I'm going to say admin 01, I get an error, invalid username or password. But I think admin should bring me in. Okay, invalid username or password. So this is just like an example to show how this works. So user 1 and pass 1. Okay, let me try it again. So user 1 and pass 1. No, user 1. Okay, go back. User 1 and pass 1. Okay, let's see what I'm sharing. Okay. User 1. Okay, so can you see my screen?
Yes.
Can you see the? Okay, let me see. Can you see what do you see currently? The RStudio, right?
Which
You
part?
see RStudio. You only see the RStudio, not what has been generated, like the Shiny app that's
Yeah,
generated.
just RStudio.
Okay. So I think I should stop sharing and show that. Maybe I have to just make this to so share. Okay, so I believe you should be able to see both screens now.
I see your browser right now.
Okay, can you see RStudio now?
Yeah.
Okay, so running this app, I get this results, and then I think this should work. Yes, it does. So I can access this app because in the Shiny app itself, the password is made available and the username is made available. But let me go back to this. Okay. But when I tried to use credentials that were not going to work, I got invalid username and password. Okay. Okay, so the credentials for this particular Shiny app are in the server side of this app, but they should be in the config.yml .yml file. Okay, so we could move on from there and it's just one of the examples that shows like the logout UI, the use of the logout UI function, the login UI function, and the login server and the logout server and that. When accessing an API or database in our Shiny Impute use client-side validation and often requires to provide credentials such as login name and password. Another example of Shiny Impute using client-side validation is the example below here. Impute performed by JavaScript in the browser, where it's possible for an attacker to send unexpected values. Okay, so for this, we have this list of say personal informations as ABCD, and then we have only two of this values in this list, or let me say, or objects in this list allowed to be shown in the, or allowed to be selected. Because if you run this, you get the select impute, and the select impute you have two choices based on the objects. Let me see the values in the allowed objects. And when you access this, you only find the name and the birthday. An attacker can open up a JavaScript console in their browser and run shiny.set impute value x, c, boom, and to see client data that are not allowed to see. And so with this, it's possible for him to see your social security number or your credit card number. So for this reason, you have to add like a layer of security in the server side, and that's where you use the require function. This ensures that values are available, and if any of the given value is not truthy, the operation is stopped by raising a silent exception. So we would be using this particular function, impute $x, and then the in operator allowed. Then after this, you should be able to keep your order information away from any prying eyes. And in case you want to skip the authentication step when testing the app, use test.skip, and so when skip tests that require authentication. Okay. So for the next slide, as to the computing resource. So what we just completed now is about the data, protecting your personal information and all the data you don't want other prying eyes to see. Now we're going to talk about the computing resource. How about errors, holes, dangerous function combination, and selective characters such as special characters that are not recognizable by the system language? What can be done to prevent unexpected values from being used? Malicious attackers can run any error code they want, delete important files, modify the data, or send confidential data back to the user of the app. You should never source an uploaded .r file. R markdown render function. You should never R markdown. You should never use the render function. Okay, wait. Okay, don't use the render function to upload. This looks quite confusing. An uploaded.rmd file. So mind the combination of pass and eval, the pass function and eval function as big warning signs for any Shiny app. So I think they just give us like what to be considerate of, like some things to look out for, which has been like examples of what to look out for. And danger, it's possible to ask how to execute arbitrary code inside a model formula. I think this I saw this in a book. Here are some example of dangerous app chunks. So this, for example, shows how the combination of pass and eval, the pass function and eval function allows user to insert only numeric variable values. Server function, then this. This would only allow numeric values. This particular chunk of code here. Then the second one, other kind of possibility for error change generator are given by the model formula, and the formula can execute an extra command prints, and this prints high. And then third one, it comes from the glue package. Okay. The book in this case suggests to pay attention to use. So you could glue this to the title and print high, and suggest to substitute with glue safe, which instead releases an error or warning. So if you use glue safe, you get an error / warning, which tells you, okay, what you're not doing right in that case. So I think at this point, I wasn't totally clear here for 4. In case of variable transformation, this is what can happen. Do you really name your son Robert? Drop table student. Oh yes, little Bobby tables, we call him. This wasn't so clear. Maybe I didn't get the joke really. Maybe it is. The code to construct a SQL query with paste function leads to flexibility in the code construction that will allow the addition of extra character not warned or advised by any friendly error message. So this function here makes it possible for me to use the provide an argument name that makes it possible. Okay, this find student function makes it possible for me to provide an argument name which selects search for that particular. Okay, I think you dropped a message. Good. Okay. Okay, let's see this.
Yeah,
Oh,
that just explains the comic. Wait, is that?
okay.
Yeah. The third panel, that's the rest of it.
Well, we'll have lost this yesterday. I hope you're happy. I hope. Okay. Okay, I think I kind of get it now.
Yeah, like that
Okay.
drop statement, just like since they named their kid that when they enter that into the table, that just drops everything in the table, like as a
Okay.
command. So that
Okay. Okay, so
yeah, you have to be careful to like not let your databases have that done to you.
Okay. So towards the end of this, find student Hadley. So then what this returns is select all from students, which is the table where name is equals to Hadley. Find student Robert, drop table students. So the solution to this is use the glue. Use the glue SQL function. If you use this, it solves the problem, and then you'll be able to like get what you need to get done. I think this completes this slide, and then we move to publishing on shinyapp.io. Security for your application running on shinyapp.io. All access to the apps is over SSL. You can configure your app to require authentication before anyone accessing it. In addition, every account has its subdirectory structure as a double layer of security. So it's like the book is recommending shinyapp.io exclusively here, and it's a good way to protect your applications after you're done working on them. So in conclusion, securing an app might require some extra work around all the information available, as well as all the extra available packages and functions that can be used for authenticating, and avoid the wrongful combination of functions or commands, which we actually mentioned. That's the pass function, which one of the examples, using the pass and eval function. This might be the case for app containing sensitive information, and that's personal information, PIs, or for those letting users access restricted data. I think we talked about that when we mentioned the fact that the attacker could decide to access other information in the data, such as by just subsetting that data that is interested in. Okay, so for the resources, other resources that we could actually look into include securing Shiny password. All these are links to other useful tips on how to secure your Shiny app. Then there are extra packages you could look at within some of them, and many more information. I think I saw something regarding this cryptography, and I think in one of the course video, it mentioned the fact that it's not so good at, is not an expert at it. He would advise you to study more before doing something or doing anything or two regarding that. And I think one of the course videos mentioned the fact that this is actually like not even a chapter. It's like a study on its own. Securing apps, like a study on its own. You have to go through it properly, understand it, then implementation becomes easier. And at this point, you can check out those videos I mentioned. I referenced Cohort 1's video, I referenced Cohort 2 videos, but Cohort 3, I didn't actually check Cohort 3 video, not for any reason, but because of for time sake. Yes, I just remembered in the book, that particular talk that was mentioned by Hadley, which was by Colin Gillespie, the video actually has he mentioned the fact that several persons don't use like very strong passwords, or probably just let out. It's kind of I think the video just shows how it's easy to like hack some persons, how it could be easy because of they're not like securing their accounts properly. You see some interviews where they will ask questions and this will just dole out their passwords and their username so easily. So I think you could check out those links and get to see what this is all about. So for more information, you can actually still check the books chapter. You could get more information from there. And our next chapter will be on performance, and there's nobody signing up to take that yet. And I believe it's going to be an interesting chapter, and they're about because and also the efficient R programming book, which is also freely available online, actually says a thing or two about. There's some packages that are mentioned in this particular chapter that you could find more about on that in that book. And just prepare our minds for this performance chapter. And next week is actually going to be rounding up this entire this cohort, and voila, that will be the end. That will just be the end of this book club, and probably I'll join your the next cohort, which you'll be facilitating. That's the one on our packages. I think we're waiting for this course to be done on mshiny before you start that, right?
Yeah, I'll probably wait until this cohort's done. And
okay. So by next week we should be done with this. Then I will join the R packages group cohort. Then probably I'll see if it's possible for me to make have the R packages cohort and also the advanced R cohort, so that I can like solidify the existing knowledge and then not just let it lay fallow again. And I want to say thank you, Trevin, for showing up again today. I look forward to seeing you again next week, and look forward to seeing others who would probably catch up by checking this video out. And we completing this course together. It's amazing starting something and finishing it. It's like the first course I'm going to start and finish. Like I'm going to be in till the end. I want to say thank you for your time, and I look forward to seeing you again and the rest of our members next week. Have a wonderful evening, Trevin.
Let me I forgot to start, but I'll do this.